Hello everyone. So today we are going to cover map of highest peak. So this problem is asked in the bi-weekly contest of LeetCode. You can find other problem solutions as well in my channel. So now let's get into this problem statement. So here we are given an input of two-dimensional integer array is water, and we have to return another two-dimensional integer array heights as the result. So here they said if a cell is having 0, that is considered to be land. If cell is having 1, then it is considered as water. And how can we calculate the height of each cell? The height of each cell must be non-negative. Okay, if a cell is a water cell, then its height must be 0. Okay, obviously it is map of highest peak. If it is water, there will be no height for peak. Any two adjacent cells must have an absolute difference of at most 1. So what is at most 1? It can either be 0 or 1. That are the only two options because the cell must not be negative. A cell is adjacent to another cell if the former is directly north, east, south or west of the latter. So let's understand this with an example. So here is our given input matrix. Here ones are considered as water and the height of the water is going to be 0. So wherever is 1, we have 0 as the height. So now other cells are representing land and we have to put the highest height of that land so that the absolute difference between any adjacent cell is going to be 1, at most 1 point to be noted. And now, so what are the adjacent cell to any cell which is present in the north, west, east and south, not the diagonal cells. It consists of only the 4 cells from up, down, left and right. So now we are starting to fill, or we just filled 1 at all these positions. This actually satisfies the condition because every adjacent cell's difference is going to be 0 or 1. Same way every cell. So finally we filled these two cells with 2 so that the difference between these two cells are going to be 1 and 2 and 2 is going to be 0. 0 can be also the height, or sorry, the absolute difference. So now how are we going to approach this? Straight away, whenever we hit a 2D array problem, first thing that hits our head is going to be BFS. So again we are going to solve this using BFS. So let's see how are we going to do it. So let's see first how are we going to fill our array and then get into how actual program gonna work. So first, obviously as we know, waters are going to have height 0. So the first thing we are going to fill is the heights of water. So it is going to be 0 and 0 where we have 1 in our input array. So next we're going to start filling our land cells by comparing the 0 first, because we know the maximum absolute highest difference between two adjacent cells are at most 1. That is, they either can be 0 or 1. If we are filling zeros next to zeros, that is not possible because the values of land must not be 0. Only water should be 0. In that case, we cannot fill zeros. So if we fill 1 next to zeros only, we will get the absolute difference of 1. Otherwise, if we fill greater values, it will go greater. So the only possible values around zeros are ones. So now let's fill ones around the zeros. So it can be 1 and 1 to its left and down. It will not consider the diagonal cells. So now for this 0, we are going to fill 1, 1 and 1 around them. So now we are filled with our ones. We have left with 2 other cells. Since we have filled around zeros, now we can fill 2's. Why? Because the absolute difference can be at most 1. So we can't fill zeros and the option left is 2. By filling 2's next to 1, the absolute difference is going to become 1. So we are going to fill 2's here. So now if you check, the difference between 1 and 1 and 2 is going to be 1, and the difference between 2 and 2 is 0, which actually satisfies our condition. So this is how we're going to fill our arrays in 3 passes. So first we're going to fill with zeros and then ones adjacent to zeros and then remaining cells with 2. So now let's see how our program exactly gonna work. So when I say BFS, our hero is Q here. So we're gonna have Q, which is gonna hold integer array, where integer array represent the I and J coordinates of a cell. So our array is gonna be having indexes 0 to 2, since it is a 3 cross 3 matrix, and our first cell is gonna represent 0 comma 0, and the last cell is gonna represent 2 comma 2. So this queue is gonna hold the indexes or the positions of each cell. So as I said, we're gonna fill our zeros first. Let's have our output array, and our output array is first filled with minus ones to indicate us these cells are not visited yet. Minus 1 indicates that the cells are not visited. We're going to fill with zeros first. In this case, we're going to iterate all the array to find where there is a 1 or there is a water. So we are going to put that index to our queue, which is 0 comma 2, and then fill that in our height array with 0. So now moving on to our second one, which is here at 1 comma 0, I'm gonna add that index to my queue and put 1 comma 0 cell at height to 0. So now we have added these two and we done with filling our zeros because we don't have any other water bodies in our given input. So now it's time to poll these indexes and iterate their adjacent cells. So now 0 comma 2, I'm taking 0 comma 2, 0 comma 2 is here, which adjacent cell is going to be 1 comma 2 and 0 comma 1. So now I'm gonna pull this out from my queue. Since I found the adjacents, I'm gonna fill its adjacent with 1 and add them to queue. So here our queue is gonna have 0 comma 1 and 1 comma 2 and fill those positions with 1. So now I'm gonna pop the next index from Q, that is 1 comma 0, whose adjacent cells are going to be 0 comma 0. So Q is gonna have further 0 comma 0 and 1 comma 1 and 0 comma 2. So I'm gonna update these three cells again with value 1. So now we filled with all the adjacent cells next to 0 with 1s. So now time to pop our next value from the queue. So we are going to pop 0 comma 1. So where is 0 comma 1? It is here. We are going to check whether its adjacent values are already filled or not. So how do we find they are filled? If it is not minus 1, it is filled already. So here in our resultant matrix, this is our 0 comma 1. Its adjacent cells are actually filled. So we are going to take it off from the queue. So next, moving on to 1 comma 2. 1 comma 2 is this cell. We are going to check whether its adjacent cells are already filled. The upper cell is filled, the left hand side cell is filled, there is no right side. So one more cell is not filled, which is down cell. For the first iteration, we filled all indexes with ones. The next we are going to fill with height 2 because we moved to the third pass. So I'm going to fill 2 here. And finally we are done with 1 comma 2. So we are going to take 0 comma 0 from Q. From 0 comma 0, if you see, all its adjacent cells are already filled. So we are skipping it and moving to 1 comma 1. So if you see 1 comma 1, 1 comma 1's left, right and up cell is filled. Down cell is still yet to be filled. So we are going to fill it with 2. Once that is done, we are done with 1 comma 1. So now finally we are moving on to 0 comma 2. So 0 comma 2 is already filled and its adjacent values are also already filled. So our queue is empty. We are done with visiting all the cells and we are going to return our height array. So let's see how we're going to code it. So before going to code, it is actually going to work in big O of yum n, where yum and n are the size of column, number of columns and rows in a given input matrix. So let's see the code. As we always do, I'm going to declare a directions array to calculate all our directions or adjacent cells from the given row and column. I'm gonna have my rows and columns declared as m and n. And finally, we're gonna have a resultant array height of same size of our is water. And I'm gonna have a hero q, which is gonna hold an integer array. Now let's start iterating our rows and columns. So I is gonna be the rows. And I'm checking if my input arrays index is going to be water body, that is equal to 1, then I'm going to fill my heights array as 0 because the height of water is 0, and I'm going to add that index to my queue. So if it is not is equal to 1, then I'm going to update my height array with -1 because those things are not going to be visited at my first run. So I filled my first pass of height with zeros wherever I find my water body, and the rest of the cells are going to be -1. So once that is done, I'm gonna write my while loop. It is gonna poll the values from queue until the queue is empty. So I'm gonna take each cell and calculate its adjacent cells value. For that, in new I is going to be cell of 0. Sorry, row is going to be cell of 0 and column is going to be cell of 1. And we know only it is going to point at 4 directions, that is north, south, east and west. We're gonna iterate our for loop for 4 times and calculate 4 different directions, positions, indexes. X is equal to row plus directions of k, and y is equal to column plus directions of k plus 1. And we're gonna check if my x is greater than or equal to 0 and x is less than number of columns, rows, and y is greater than or equal to 0 and y is less than my number of rows, columns, and height is greater than 0. Sorry, height is less than 0, because if it is less than 0, which means -1, which means the cell is not visited yet. Only if the cell is not visited, we gonna update the value or update the height. If not, we simply gonna ignore. So finally, we're gonna update our height at that position is equal to whatever height is there in the cell plus 1. There in the adjacent cell plus 1. If the adjacent cell is having zeros, it is gonna fill with ones. If it is 1, it is gonna fill with 2 because the absolute difference is gonna be 1. So finally, once we are added, we are going to add that cell to our queue. Yes, so let's run. Finally, we return our height. Okay. Yes, the solution is accepted. Yes, it runs perfectly fine. So thanks for watching. If you do like the video, hit like and subscribe. Thank you.